This question is at the end of chapter 9. It's question 35. And as I've written, it's 35-ish. A little bit different than what's verbatim written in the textbook. But anyway, we are determining what they are asking for. I've just written it out a little bit differently. So elemental phosphorus, and I would give you on a test, tell you that that's P4, burns in oxygen. That's oxygen gas, so that would be O2 gas. It burns in oxygen with an intensely hot flame. So you would recognize this as a characteristic description of combustion, producing clouds of white diphosphorus pentoxide. There is a more common name, but I would write it this way so that you could determine the formula from this molecular compound. White diphosphorus pentoxide solid particles. So that's what smoke is. We know that. Finely divided particles. And so that's a solid. The question is, what mass of oxygen gas is required to completely burn or consume or combust 4.95 grams of this P4 solid phosphorus? And so you want to start with your balanced chemical reaction. So I wouldn't give you this reaction. I think the book has. So you would need, you would be at this point answering it, say, in a test or exam situation. And so you want to read that description again. So you know that P4 is a reactant. It burns in oxygen. That means it's combining with O2 gas. And we see what comes out is the diphosphorus pentoxide solid. So there you have it. And you have to balance it. The phosphorus was what I balanced first. So the 4 on the left, there was 2 only on the right hand side. So a 2 in front gives you the 2 times 2, 4 phosphorus on the right hand side to match the 4 on the left. But the 2 coefficient in front of the P2O5 compound gives you 10 oxygen atoms on the right hand side, the product side, and therefore required the 5 in front of the O2 gas to give 10 oxygen on the left. And so that was the balanced chemical reaction. The question is only giving you the mass of one of the reactants, and instead of asking you for the mass of product that is formed, and that there are very many examples of that kind of question in the text at the end of chapter 9. I like this one because it's really showing you that this balanced chemical reaction relates all the species, reactants and products together in this reaction through the fact that it's balanced, and so through the molar ratio. And so they're asking you how much oxygen is required to react completely with this phosphorus. So start with the balanced chemical reaction, got it? And then think about what you want to do in terms of a calculation or conversion pathway. So we're starting with the mass of phosphorus. So we are starting with the mass of a reactant. And what we'll do then is, if they give you a mass of one reactant and they're asking you what mass of the other reactant do you need to react completely with the mass of the first one, again, you always have to work in moles. So you need to convert the mass of phosphorus to a number of moles of phosphorus. And then once you're in moles, you know that 1 mole of phosphorus would require 5 moles of O2. So this many moles of phosphorus, and by this I mean the product of that little box there, calculation, that many moles requires how many moles of oxygen? oops, sorry, and that's the conversion factor here. I know that it's 5 to 1. And so in this question, I'm not calculating and stopping and trimming sig figs as I go. I'm just doing it all in one line, and that's what you want to aim for. So this is my mass of phosphorus converted to moles of phosphorus, converted to a corresponding number of moles of oxygen required to react with that many moles of phosphorus. And then that number of moles of oxygen required to react with that many moles of phosphorus is now converted to a corresponding mass of oxygen, because that's what I'm asked for. So mass to moles, back out to mass. So as you're migrating through a balanced equation, you're always working in moles when you want to talk one reactant to another or one reactant to a product. And 3 sig fig answer is 6.93 grams. All right. So very important here, not just to put grams and moles, but to say grams of P4, because the grams of P4 cancel with grams of P4, not with grams of oxygen, for example. So this one is a good example of how to do that multi-step conversion pathway. And this is what we mean by showing all of your units. And I haven't struck out to show cancellations, but you can see where the diagonal units would cancel. Grams of P4 goes out with grams of P4, and moles of P4 out with moles of P4, and moles of oxygen with moles of oxygen, and I'm left just with grams of O2. So you know that you've arrived at the right answer. You just have to plug the numbers in to get the right value. All right, so this is a good question.